If you feel like you're capable of more, but you don't have a clear path to get there, you're in the right place. This is the Career Code Journey, and here I talk about everything you need to know to become a developer without rushing, guessing, or doing it alone. My name is Cindy de Albuquerque, and today's episode is Why is Testing More Important Than Coding? Just a quick introduction. I have been working as a software developer for 18 years. I've worked in many companies from startups to large companies like Amazon. But then I transitioned to Java developer. What is this topic? It's a fundamental mindset in software development that prioritizes quality of the product above everything else. The process of ensuring that the software is working, testing, is more important than simply writing the coding. It means thinking like an end user or a quality auditor right from the beginning of the project. It involves intentionally creating usage and failure scenarios to validate your code, ensuring that it not only works, but that it is secure, reliable, and bug-free. It's a paradigm shift. Instead of building and then fixing, you build so it won't break. I'm not saying that coding is useless or less valued. On the contrary, it increases the quality of programming. The message here is not that you should spend all your time writing tests instead of functional code. This is also not a justification to write poor quality code, because you could believe that the tests would fix all your problems. This topic is also not about disorganized manual testing. The focus is to integrate the testing mindset into the development process so that your code is cleaner, more efficient, and more reliable. Why is this an opportunity for you? First, there is a fast entry point. The area of QA, quality assurance, and software testing is one of the most accessible paths into tech. You don't need years of programming experience. It's a critical function that demands logical thinking and attention to detail. These skills can be quickly developed. There is also a high market demand because the tech companies put a lot of value on the quality of their products. Professionals who demonstrate a strong testing mindset and experience in test automation are extremely sought after. This is also a strategic positioning. You stand out from the majority of beginners who only focus on coding. When you are genuinely concerned about the quality of your program, you add more value to the user, and you are also contributing for the long-term health of the project. All these characteristics are highly desirable in any development team. You might be thinking, I already don't have time. I can't spend time on tests. But let me tell you something. The time you invest in tests is not a waste of time. It's actually time saving. If you adopt the mindset of testing your code since the beginning, you spend less time in the future fixing bugs. This is one of the most time-consuming and frustration tasks in development. The shortcut to a successful career isn't skipping steps. It is mastering the right steps to become a valued professional. You might also be thinking, I need to learn program to get a job, not how to test. I understand that. It's a valid point. But there are two main points here. First, the importance of testing in software development. And second, the QA, quality assurance, career path. It doesn't matter your preference. Testing will be a fundamental part of your career. Most advanced tech companies have this mindset. What most beginners don't realize is that learning to code for the current job market doesn't just mean writing code. It means writing quality, reliable, and sustainable code. That's where the culture of tests come into play. The culture of tests in tech companies is so strong that in many cases, testing is viewed as the first step, not the last. This is where test-driven development, TDD, comes into play. It's a methodology that has become the standard in many tech companies. In practice, a developer who follows TDD doesn't write a line of functional code without first writing the test that is guaranteed to fail. Then they write the code to make the test pass. This ensures that the final code works, but also meets a specific requirement and has a great quality. TDD changes the developer mindset. You start to focus on solving the problems in a reliable way. The standard of tech companies in Ireland is to prioritize delivery with quality and agility. So much so that when you want to merge your code into the main code, this process is automated and has many quality barriers. You usually have to cover a certain percentage, like 70%, 80% of your code in order to be able to merge it. The tools for CI and CD, continuous integration, and continuous deployment automatically check this percentage. If you don't reach the threshold, the system will block you and you won't be able to deliver your work. So in order to do your work, you have to know how to test. In this context, learning to test is a prerequisite for having your code approved. Why is the ability of testing a competitive advantage? In the hiring process, when a candidate demonstrates that they are able to work with tests and that they know automation tools, they automatically stand out because it shows they understand the modern developed culture, the software life cycle, and the importance of quality. Instead of being a secondary skill, the ability to test is seen as a sign of professionalism, discipline, and the capacity to deliver high-level work. For anyone seeking an entry point into technology, mastering test and automation is a strategic way to position yourself as an elite professional, drastically increasing your chances of being hired. The career of QA, quality assurance, is a profession in itself, and it's very well remunerated. Many testing positions, such as test automation engineer, require programming skills. That's why learning test is a practical and effective way to develop and apply your coding skills. Testing is a route to programming, not a detour. What are the biggest mistakes people make about testing? First, treating tests as a final step. The most common mistake is thinking that testing is something you do only after the code is ready. Ideally, testing should be a continuous process, starting from the initial stages of software planning and design. Second mistake, confusing test with console.log. Many people use commands like that to check if their code works. This isn't testing, it's a verification. A real test is automated, is able to be reproduced, and covers different scenarios. Mistake number 3, ignoring automation. Focusing only on manual tests is a mistake because it limits scalability and efficiency. The job market values professionals who know how to create automated tests that run repeatedly and ensure changes don't break the code. That's why you should take a structured approach. Understand the fundamentals. Learn the concepts of unity, integration, and end-to-end tests. Understand the difference and importance of each one. Start with the essentials. Choose a popular programming language like Python, Java, .NET, and learn a testing framework. For example, PyTest or JUnit. Adopt the TDD, test-driven development. Learn to write the test before you write the code. This forces you to think clearly about the solution. This way you build cleaner and more modular code. Build a testing portfolio. Create small projects and publish them on GitHub. This way you are going to show not only your code, but also the tests that you wrote. This proves that you care about quality and that you have the skills the tech market is looking for. Now let's build a small program with TDD. Let's assume the following scenario. A restaurant has decided to partner with a few companies. The employees of these companies will receive a 10% discount on the final bill amount. Let's create a method that calculates the 10% discount on a value. We are going to create a method that receives the value and will calculate the 10% of discount and will return the final bill amount. The result should be the final value with the discount already applied. Okay, so to achieve that, we're first going to create the test. I'm going to come here, new Java class, and I'll name let's name it build test. Oops. Build test. Okay. So we're going to create the test. What do we want to test? What is the happy path of this program? we receive a value and we return the bill with 10% discount. So let's create this happy path, the happy path test. We want to have a bill, but we don't have this bill. But in my test, I ideally would like to have like this, to instantiate a new bill. But I don't have my bill, so I have to create it. So let's create the bill. The idea here is that we need to do the minimum needed to make this test work. Okay, so I need the bill, and in the bill I want to have a method that apply discount. So I will add here apply discount, and I don't have the apply discount method, so I have to create it in the bill class. What I do here is I just go to the red icon here, and I'll create the method. So far it's working. But in this apply discount method, I need to pass a value, the value of the bill. So let's use a big decimal. Because in Java, when you need to use money, you have to use big decimal for precision. Bill value will be a new big decimal. Let's say I went to the restaurant and I spent 8 euros. So now I want to pass this bill value to my function apply discount. But my function apply discount also doesn't have the bill value, so we have to add it. It's there now. What we want from this method? We want it to return the bill value with the discount. So the bill value is also money. We are going to use another big decimal, and this will be, I'll put bill value with discount. But there's an issue here because our method doesn't return anything. It's a void method, so it doesn't return anything. So we have to make it return it. Okay. Now it returns, well, it added the bill value. So now it returns, it's returning the bill value. So it's doing nothing. And what I want to compare the bill value with discount to a new value. So I'll create here, I'll duplicate this line, bill value with discount. Expected. It will be 80 minus 10%, which will be 72. Instead, I will put actual bill value with discount, so we know the difference. So this is the actual one, this is the expected one. We want to compare them, and we want them to be equal. This test will fail. Why? Because bill value with discount expected is 72, and my method is only returning the bill value. So I'm expecting it to fail. So we are going to write an assertion here to make sure that this actual value is the same as the expected one. How do we compare big decimals? You can't use equals. You have to use the compare to method. And the compare to method returns 0 if they are equal. So we are actually going to do assert equals 0 because it's the expected value of the comparison. And we are going to do the bill value with discount expected, and we are going to compare it with the bill value, the actual bill value with discount. This is going to fail because the actual bill value is greater than this. So let's run it to make sure that it's, oh yeah, I forgot to add here, we have to add a test. Okay, so now we can run this test. And yeah, the happy path has failed as expected. So we have to write the minimum code to make this test pass. So what is the minimum code? We return 72. Because then the expected and the actual will be the same. So this is the minimum. Okay. So now as they are returning the same value, I want it to work. Let's run it again. It passed. Great. Let's write another test. We know that if the customer has a bill of 80, this will work. But we don't want it to work only for 80. We want it to work for every value. So let's duplicate this code for a different value. And we know that this is going to fail. So let's do a bill value 2, and it will start, let's say, with 100 euros. This is going to be the second expected, and the value here is 90. And then when we apply the discount for the bill value number 2, we want it to be 90. So let's fix this test. Yeah. Okay, so now when we run, we are expecting it to fail because it returns 72. Great. It says that here it's failing. Okay, so now let's write the code. So instead of returning new big decimal, we are returning the bill value. We're going to multiply. So what we're going to do, we're going to multiply the bill value to 0.9. It's complaining here, so let's do like this. It stops complaining. We expect our test to run properly. Let's run it. It passed. Okay, this is the happy path. In the real world, this would work, but there are some edge cases that we haven't thought about here. For example, let's create another test. So what should happen if whoever is calling the function doesn't pass the right value, but passes a null value, to avoid the null pointer exception? What do we want to do? Do we want to return 0? Okay, so let's suppose we are going to return 0. So let's write should return 0 when bill value is null. Whoever reads this test will know the test scenario that we are doing here. So we can copy this, and instead of bill value, we are going to pass null here. And we want to make sure that the actual bill value is 0. We want to compare 0 to the actual bill value with discount, that it's a big decimal. We want to make sure that whenever our bill is null, we are returning 0. This is going to fail. This is actually going to throw a null pointer exception because the bill value is null. Let's run this test. Of course, I forgot that it's a test. Now it's runnable. And yeah, no pointer exception. Okay, so let's fix our code. What should happen if bill value is null? We return big decimal 0. Now this should work. Okay, what should happen if someone calls this method with a negative value? Of course, in the real world, we might think that no one will call this method with a negative value. But that's not true, because there are bugs. There are things that even the most experienced developers might not think. So we have to protect our code from anything that is external. So let's do it. Let's add another test. And what would we like for it to return? Should return 0 when build value is negative. Or maybe we could throw an exception. Should throw exception when build value is negative. For example, illegal argument exception. So let's add it here. Illegal argument exception when build value is negative. We can also change the behavior here and maybe return an illegal argument exception. But let's focus on this first, okay? Then we can change it. After this is working, we can change it. Okay, so we want something similar to this. Instead of null, we're going to pass a big decimal. Let's say -1. So we want to validate if an illegal argument exception is thrown when we are calling this method with a negative value. So how do we do that in JUnit? There are a few options, but the modern way is with assert throws. So we'll add illegal argument exception here, and we'll add the lambda function of calling our method. Okay, so now our method is not throwing an illegal argument exception, so we are expecting this test to fail. And it was expecting an illegal argument exception, but nothing happened. So we have to now fix our test. So I'm going to duplicate this. If build value compared to 0, this means that the value is negative. Then we're going to throw a new illegal argument exception. Illegal argument exception. So let's run it again, and it should pass. So now that we have the tests, we can refactor our code, because if you break anything, the tests will fail. So let's suppose we want to change here. So let's suppose instead of returning 0, we want to throw an illegal argument exception when the build value is null. So let's change the test case scenario here. And instead of assert equals, we'll have assert throws. This will be the illegal argument exception. And we are going to put this inside, and we can delete this. Of course, it's missing the lambda. Okay, we know that this is the new behavior that we want from our method, but we haven't changed it. So when we run it, it's going to fail. because it's expecting the illegal argument exception. So let's change. If bill value equals null, we can use here. If bill value is null or it's negative, it throws a new illegal argument exception. Okay, awesome. So now it should, okay, it's working. Let's see if everything is still working. And let's run the whole thing. So, okay, so whatever we added to the bill class, however we refactored it, didn't break our tests. So, okay, it's passing. So, okay, it's passing. Did you like this video? Are there any other test scenarios that you would like me to talk about? If you liked it, please leave a like, share with whoever you think might be benefited with this video, and subscribe to the channel.